All right, welcome to Lesson 9. Now, let's consider first how we normally multiply two numbers. For example, let's multiply the numbers 342 times 23 the way we normally do. So, in order to do that, we take 342 and multiply it by 23. And we do that. Yeah, I don't mean on the calculator. We're going to do it by hand, okay? So, first thing we do is to take the 3 and multiply it by the 2. I get 6. And then I take the 3, multiply it by the 4, and I get 12. I write the 2 down here. I carry the 1 up here, and I take the 3, multiply it by the 3. I get 9. Add the 1, I get 10. So I write the 10 right here. Now, in order to do the next line, I work with the 2's. I take 2 times 2, and I get 4, and I put it right here. And then I take the 2 and multiply it by the 4, and I get 8. And then I take the 2, multiply it by the 3, and I get 6. And then I got two lines of numbers which I add together. And I get the 6 here, I get a 6 here, I get an 8 here, and I get a 7 here. And that's what you should get when you multiply 342 times 23. Now, let's look at multiplying them using the box method that we've been using for multiplying polynomials together. All right, 342 is the same as 300 plus 40 plus 2. If I add all three of those numbers together, I get 342. I can also break down 23 in saying that it's 20 plus 3. And when I do that, I can now multiply each box together. So when I do that, I am going to take 20 times 300. That is 6,000. I'm going to take 20 times 40, which is 800. And I'm going to take 20 times 2, which is 40. I'm also going to take 3 times 300, which is 900. I'm going to take 3 times 40, which is 120. And I'm going to take 3 times 2, which is 6. And if I add all those together, well, let's do it the diagonals like we've done it before. 800 plus 900 is, and let's do this in blue, that is going to be 1,700. And the blue here, 120 plus 40 is, that is 160. And then I add them to the 6,000 up here and the 6 down here. I get 6,000 plus 1,700, oops, I forgot the last 0, plus 160 plus 6. And I add all those together, I get 6 here, I get 6 here, I get 8 here, and I get 7 here. So I get the same answer down here as I got up here. So I can use them for numbers just like I use them for letters. We are going to return to multiplying polynomials together. This time we're doing something with 3 terms times something with 2 terms. So let's get started on that, shall we? On the top, I'm going to put 3x squared. Notice I have 3 boxes by 2 boxes. And the reason I got that is because I have 3 terms here and 2 terms here. So very simply, what I'm going to do, let me make that 3 neat. is I'm going to put my 3 terms up here. So 3x squared plus 4x plus 2. And I'm going to put my 2 terms over here. So that's 2x and plus 3. Okay, so 2x times 3x squared, that is 6x cubed. 2x times 4x is 8x squared. 2x times 2 is 4x. And then I'm going to take my 3 and multiply it by 3x squared. I get 9x squared. 3 times 4x gets me 12x. And 3 times 2 gets me 6. Now, when I do this, I add my diagonals. Well, there is only one term in that diagonal. There's 2 terms in this diagonal. There's 2 terms in that diagonal, and there's only 1 term in that diagonal. But look at the thing that's neat about the diagonals. I have nothing but x cubes in this diagonal. I got nothing but x squareds in this diagonal, and I got nothing but x's in this diagonal, and I got 6 in that diagonal. So what I can do is I can say 6x cubed, and then this diagonal right here, I take 8x squared plus 9x squared gives me 17x squared, and then 4x plus 12x gets me 16x plus 6. And I have just multiplied my first 3 by 2 polynomial. Okay? So let's, did the same thing there. Let's cross that out and move on to the next slide. Now, the expression 10x squared plus 6x cubed is the result of applying the distributive property to the expression 2x squared times the quantity 5 plus x cubed. And what I'm asking you to do is to verify that these 2 expressions are equal. So here's what I'm going to do. Let's set this up. I'm going to see that 5 plus 3x times 2x squared, if that is indeed equal to this right here. So, my first order of business, I'm going to erase this so that it does not get in the way of what I've written. I am going to ask you, this term right here, this 2x squared times 5 is what? And you want to say 10x squared is the result of multiplying those 2 things. And then when I multiply 2x times 3x, oh, I'm sorry, not 2x, 2x squared times 3x, for this box, I am going to get 6x cubed. And that is adding those. So now, the answer to my question is 10x squared plus 6x cubed the same thing as this expression up here? And it looks like it is. As you can see, 10x squared plus 6x cubed is the same as this 10x squared plus 6x cubed. So we have done something. We have verified that this right here is the factored form of this guy right here. And factoring is something that we do when we do multiplication backwards. We call it factoring. And factoring is a nice little tool to help us make sense of things when we need to make things either simpler or more easy to understand. So, let's consider factoring the expression. I like this highlighter. Let's consider factoring the expression 2x to the 4th plus 2x to the 5th plus 2x to the 10th. So what two things multiplied to each other get me that expression? So the first thing I'm going to ask you is, what do all three terms of this expression have in common? So let's break that down a little bit. First things first. 2x to the 4th. What is that? Well, it's simply, I don't want black. I want black. It is simply 2 times x to the 4th. And 2x to the 5th is 2 times x to the 5th. And 2x to the 10th is 2 times x to the 10th. Now, if we look, every one of these has a 2 in common. Do you see that? Everything's got a 2 in the common. And it's got x's in common as well. If you look at that, everything's got x's in common. But if you notice as well, the numbers up top are different. So what do those mean? Well, x to the 4th is simply x times x times x times x. It is x times itself 4 times. Okay? X to the 5th is simply x times x times x times x times x. And it is x times itself 5 times. Not x times 5, but x times itself 5 times. There's a big difference in that. And then down here, x to the 10th, I'm going to need some room here. This is x times x times x times x times x times x, that's 6, times x times x times x times x. That is x times itself 10 times. So, when I ask you, what do all three of these terms have in common? Well, they all have this 2 here. Oh, goodness. I don't want to do that. I want to do this. They all have this 2 here. All three of them have a 2. All three of them have a 2. And then, how many x's do all three of these have in common? Well, this one has 4 x's. Okay? Well, this one has 4 x's, and this one has 4 x's. Do any of them have more than 4 x's? Well, yes. This one has a 5th x. This one has a 5th x. So does this one. And this one, x to the 10th, has a bunch more x's. But notice, only one color is applicable to all three of them. Only one color, and that's yellow, right? So I only have 4 x's in the bunch. So what I want to do then is, what I have in common is 2 times x times x times x times x. And that is simply, I'll do this in black, 2x to the 4th. Now, when I do that, I'm left over with 1 plus x plus x to the, how many do I have left? I had 6 left. And let's multiply through, let's distribute to make sure I did this right. I got 2x to the 4th times 1. Oops, I'm sorry. We're going to do the box method, and we're going to say 2x to the 4th. Oh my goodness, that is awful. There we go. There's my box, and there's my box. And I'm going to look at 1 plus x plus x to the 6th. And I want to see that I get what I originally started out with. So when I take 2x to the 4th times 1, I get 2x to the 4th. If I take 2x to the 4th times x, I get 2x to the 4th, or 2x to the 5th rather. And when I take 2x to the 4th times x to the 6th, I get 2x to the 10th. And I start out, or I end up with what I started out with. I end up with 2x to the 4th plus 2x to the 5th plus 2x to the 10th. Oops, I didn't like how I did that, so let me do that over again. The 10th goes up here, not down there. And that's what I started out with. So I know that this right here, and I'll highlight it, is my factored version of this in yellow here. And there you have it.